Elektor Business TV, again at Electronica 2016, has landed at a booth with at least 3 different names. Trinamic, Michael Randt. What's the pronunciation, Michael? Please help us out.
Oh, the German one is Trinamic, of course, yeah. But we are an international company. We sell most of our products outside Germany, so it's Trinamic. But I personally like Trinamic, the French one.
Yes. It has a nice ring, whereas the English pronunciation Trinamic, dynamic. Are you at a dynamic company at all?
Yes, we are. I think so. Yeah, we are
How?
really dynamic and. First, of course, we're growing, we're pushing technology. That is most important for us, and we believe that our products controlling the large amounts of small motors that are basically everywhere can create a better world. Yeah, so. And that's what we're pushing.
A bit later about the motor stuff, Michael. First of all, Trinamic is involved in the Fast Forward Awards as well, with the Elektor Fast Forward Awards as a sponsor. How do you view the general, the process of people starting up and getting encouragement from starting up and achieving company status? How did you achieve company status?
Oh wow. Well, when I thought about this interview, I really had to go back in time, more like to the 1980s, and I remembered that my first real computer was an Elektor Junior computer.
No kidding, 6502.
Oh yeah, Rockwell 6502 CPU, and my background is I'm a double E. I'm an electrical engineer. And I always wanted to be an engineer, and I was always interested in electric motors. Yeah, so when
doing something useful with electronics, getting the motion to cease.
First, I was interested when I started to study. That was in the 1980s. I first learned to design electric motors, but when the first microcontrollers or microprocessors came up, I was fascinated with the possibility to control electric motors with these computers. So the first thing I did is I used my Elektor computer and controlled motors. And basically we're still doing the same thing. We are building now our own chips that control electric motors in a superior way. But
there is something very powerful and funny, also interesting about having a very small microcontroller with software doing something with a very powerful motor, isn't it?
Yes, and well,
How does Trinamic do that?
We do a lot of things not in software, but in hardware. So some IP cores are integrated in our chips that take care of controlling the motion or making the motors run very silent or with superior efficiency. But you asked originally why we joined this Fast Forward and so on. Of course, we are looking for people in our company, for talents who share what we believe and who are fascinated by motor and motion control.
Do you already have talents in your company?
Yeah, we have plenty of talents. I think really I have one of the best teams on the planet when it comes to motor and motion control. So, but how do we find these people? We find them by attracting talents at a very early stage. And
spotting and scouting, it's all about.
Yes, that's what it's all about. And we're not looking for the people who have the best diploma or something like. We are looking for people who are fascinated and who share the why of the company, of Trinamic, who are fascinated by motors, motion control, the things you can do with that, and who believe that you can create a better future doing this.
Okay, Michael, IoT is a big stuff, big buzzword here at the show, of course, IoT and security and stuff. Let's have a look at it a bit later. Now, I'm interested just how Trinamic actually started focusing on motor controls. Did you go through some evolution as a company?
Yes and no. The company was always about motor control and motion control. And we believe that, well, I mean, what we do is very simple. We build devices that transform digital information to perfect physical motion. Yeah, and this is what the whole IoT, or a lot of things in IoT is about.
Exactly.
Yeah.
Also at the sensor side.
Yeah. So a lot of people are, now everything is digital, right? But we have a
No way.
physical world. We live in a physical world. We have to move things. We have to. We need actuators. We need things to move, and that's very important. And
That
this
seems to be a neglected area, and that's where you step in.
it's the neglected. It requires a special expertise. You need to understand the physics of the motor. You need to understand how to build these circuits so everything is dependable. Yeah, you want dependable motion. Yeah, that is the key word of the future. And we are, since many years, we're not seeing ourselves so much in industrial motion control. We don't build boxes that you mount to the wall. We are in a market that we call embedded motion control. It's all about
Interesting term, embedded motion, yeah.
Yeah, and well, for instance, our design wins are in ATMs, yeah, like cash machines, yeah. Is this industrial motion control? Is this consumer? Yeah, so it's embedded motion control, yeah.
Good.
And this is what it's all about, yeah. So
Shall we have a look at some of your IT
yeah.
products, Michael,
yes.
on your stand here?
Yeah.
Let's do that. Let's go over to the demonstration room.
Yeah.
Yeah.
So
This looks mighty impressive. There's things spinning and swirling.
yes.
It says EtherCAT slave controller on the unit, but Michael, it begins with Ether, so that probably means there's some Ethernet connector.
Yes.
Where is it?
EtherCAT, well, that is, all the connectors are here, and you see the motors are connected with this bus system. So EtherCAT is a real-time derivative of Ethernet. Yeah? So it means that the data is transported in a deterministic way. You know exactly when the data arrives to move something. This is important if you want to synchronize drives. So what is so important about these chips is, first, we're among a handful of companies that make EtherCAT slave controllers. So you need special silicon to interconnect these devices. So what we do here is we even optimize the real-time performance by integrating special hardware units that interface directly to our drivers in these chips. So it's EtherCAT, but even better than EtherCAT.
I'm always interested whenever I see motors, when motors get slowed down or stopped or halted or whatever.
Yeah.
How does that feed back to the system? How does the microcontroller know something is going wrong there?
Yeah, it's sometimes, of course, you have encoders at the motor mounted, yeah, but there are also sensorless ways to monitor if a motor is stopped.
Yes, exactly.
So
like
we have this, for instance, for stepper motors. That's maybe change here.
let's go over. Let's go over here. This is a black box. Let's have a look.
Yeah. So it's a 3D printer. It's the most silent one because our chips are used in it.
It's
Yeah.
a mega wrap.
Yes, but one of the ideas that we realized in our chips is that you can detect a special load situation, the overload of the motor, so you don't need limit switches. So you asked about how do you detect that? Yeah, so you run to the hard stop.
You put a continuous monitoring on the motor.
Yes, that's basically.
Rather than waiting for some end stop to flag a fault condition.
Yeah, and if you look at the background, it is all about having more dependability in the systems. You want more feedback. Yeah, in the past you had an amplifier, that controlled the motor. Now it's an intelligent subsystem that gives you information back. Yeah,
exactly.
So that is basically
That also requires a lot of processing. The information which gets back is equally important as the information you send to the motor. Is that a nice summary?
Yes, and it requires special skills in mixed signal design. Yeah? So it's a mixture of digital and analog know-how that we realize in our chips. Yeah? So that's really important.
Now,
here.
Michael, you've been carrying something in your hand. I noticed that. What is that?
Yeah.
Besides your glasses, of course.
Yeah.
We always ask here at the show, what is the hottest product people can show here at the show? That's the all key question for today.
Yeah.
Now it's your turn. Trinamic.
Yeah,
Here we go.
This is my one more thing. It is the world's first.
World's first, folks.
Yeah, it's the world's first combination of a motion controller with a closed loop controller for stepper motors. So usually you use a stepping motor open loop, which means you have a nice high torque, but the efficiency is not as good. And what we did here is we built one circuit that integrates motion control, so the ramp generation, with the closed loop capability. So you have a fairly low-cost encoder mounted at the back of the motor and turn virtually the low-cost stepper motor into a high-performance servo, just by adding this component to your circuit.
Give me one, Michael. Give me one. It's for Elektor Business TV. Trinamic. Watch these guys.